we'll continue on here and look at the hardware overview. So the first section was just to give you a brief or overview of what the M1's all about. If we now look at the M1 in particular itself, we'll move on and do this. But just on this slide here, the thing of note is right down the very bottom is the sticker that's on the panel is the serial number. Whenever you're connecting with this programming software, to program the system, you need to know the serial number. The serial number is in 3 or 4 different places. The easiest way to find it's on that sticker on the bottom of clamshell. If you did take the cover off the clamshell, it's also on the circuit board. It's when you first power the keypad up, it will flash the serial number, and once you go into programming, it's in the programming there as well. So, but the easiest place to find it is the sticker on itself down the bottom. And we'll cover those other terminal blocks on the next slides. Starting off, first of all, up the top left-hand side of the clamshell is our 16 hardwired inputs. And those hardwired inputs right across all 208 inputs are programmed on a zone-by-zone basis. So they can be all individual. They can be programmed as a normally open or normally closed, meaning it doesn't need an end-of-line resistor. They can be programmed requiring an end-of-line, 2K2 end-of-line. They can be programmed for 4-state monitoring. They can be programmed as an analog input. So they're all programmed totally individually on the system. And you'll notice that all the terminal blocks on an M1 are plug-in terminal blocks. So if you want to unplug, you just unplug, and they're all various different sizes. So, for example, the zones have got a different size terminal block than, say, the power output or the relay outputs or the databus. So if you did have to unplug all the connectors, when you're plugging them back in, you can't accidentally plug in zone into the 12-volt output and cause damage. So that's one of the reasons that they're all different sizes. So the top left is you've got your 16 zones. Moving under that, the bottom left of the clamshell is for our zone is 12-volt output. First of all, up the top there, the first pair of outputs, we'll look on the left-hand side, it's 12-volt out, which is switched output. So you can then typically wire that for whatever you want to have that may need to be switched. For example, a latching smoke detector. So you can hard power the smoke detector up from that switched output. When something occurs, you can get that to turn that power off to that output, the 12-volt output, for 5 seconds. You may want to power your Ethernet module up from that. So from time to time, you may want to reset your Ethernet module. You can wire it into that 12-volt switched output, and then via the keypad, via the app, etc., you can then get that output to switch. Then there's 3 pairs of outputs following under there. Just standard 12-volt output is for connecting to powering up your motion detectors or anything 12-volt. The last pair of our inputs here is your input for your power supply. We can put AC or DC in there. On the board, it's probably still labeled as AC, 16.5-volt AC. With the new MEPS regulations, mainly in Australia, but it's continuing throughout the world, is a standby power supply has to be power efficient. You can't get really easily to get a power efficient AC supply. So we now supply the panel with a DC supply. We then can put DC in that input or AC. It doesn't matter. Then underneath that input is we've got the power, status, and reverse battery LEDs. So when we've got power on it, the power light will come on. Status light's like a little watchdog. It's flashing all the time at a nice constant rate. And if you did connect the battery, which is shown there, the battery terminal's around the wrong way, the battery reverse LED will come on. Now there's also a switch. That switch down the bottom here will switch both mains and battery. So it's fantastic for when you want to service the system rather than have to unplug the terminal block to unplug the power supply, disconnect the battery. All you need to do is turn that switch off, and when that switch is turned off, it removes both mains and battery. So you can fully service the system with one power switch. The other thing is if I want to power the system up, you have to have the mains input coming into that terminal. If I just put that switch on and got battery only, it won't power up because since there's no mains coming into the system. But there are some applications where you know there's no mains, maybe because you're testing a system, there's no power onto the premises yet, you want to power it up on battery only. So there's a jumpers or jumper pads right down the bottom, these 2 little solder pads here. If you then power that up and put a short across those inputs, then hold the short there for a couple of seconds, and you're forcing the system to power up on battery only, not on the mains coming, because there's had other instances where if it did just power up on battery only, you turn that power switch on and you thought there was mains coming in, but it was never plugged in. If the system powered up, then what happens is after 8 hours or so, battery's going to go flat. You got a service call because you didn't plug the power supply in. So it's another safeguard that when you turn that on, you know that you've got the mains coming in. If we now move across the other side of the clamshell, right up the top right-hand corner, so the top left was of the unit was the zone inputs, bottom left was the power. The top right is where the phone gets connected, your PSTN phone. You've got ring and tip, which is your incoming phone line from the telco, comes into ring and tip. And R1 and T1 is your mode 3 socket out to the house premises phone. As more and more fibre or NBN rolls into premises, everyone's losing the PSTN phone line. So what we can do is if you want to dial out on 4G, we've got the 4G dialer that plugs directly into ring and tip, and you get all the functions that you would with the normal PSTN. There's nothing to program in that 4G dialer. You just plug it in, all the phone numbers, etc. program the M1, it will just dial out. Or if you want to have GPRS monitoring back at a control room, like with Permacom, then you can plug the Permacom directly into there as well, and it will then go back. So the Ness 4G dialer will then dial voice dialing. It will go back to a control room with contact ID, or the Permacom will give you IP and 4G back up to a control room only. So you've got both options for when the customer has got NBN installed. Moving down, you can see up the top right-hand side, we've got the dialer we're just talking about. Then we've got the RS232 port that plugs into there. Now that can be used for a variety of reasons. You can plug in a RS232 to USB cable to plug into your laptop or into your computer to program it. You can plug your Ethernet module in there to be able to program or operate the system locally or remote from the Ethernet module. So the RS232 is just a standard null modem 9-pin connection, and that's where that plugs into there. Moving down, we've then got in the middle of the board, just under the RS232, we've got 10 outputs here. But let's jump down the very bottom, and we've got output 1, 2, and 3. So output 1, we'll work our way up. So output 1 showing where the black and white wires are connected on the example here. That is for your internal siren. Your inside siren is where the voice comes out of as well. So your typical horn speaker, inside horn connects in there. You can connect typically up to 6 speakers in there. Once you get above more than 6 internal sirens, then we recommend to go to a amplified voice module anyway. But you can run that down to 4 ohms. So if you put an 8 ohm horn speaker in it, of course you've got 8 ohms. You put 2 in parallel, you get 4 ohms. Put a couple in series and parallel, you can get down to 4 ohm on that input there. So that's where your internal sirens would connect. Output 2 is where it's showing a resistor in there. Output 2 is for your outside sirens. It's a supervised output, so if you're not connecting an outside siren, then you must seal that input up with an end-of-line resistor to have impedance across there. If you're using electronic 12-volt siren output, and you've got a high impedance siren, and it shows, and the system is showing that you've got a output 2 trouble, that means that output 2, it's not sensing a resistor in there or an impedance into that input. You should really then put something like an 820 ohm resistor at the siren end, because it is supervised. So if someone does cut that input, short that input out, the panel will know about it and say, hey, we've lost the outside siren. Output 3 is 3 terminals, and it's a dry contact. It's a normally open, normally closed contact, typically for where you connect the strobe. So you would connect 12 volts, for example, into the center, common, outer normally open, into one side of the positive of the strobe, and negative strobe back to 0 volts. And we can get 0 volts from a number of places. We can get 0 volts, easiest place is up on this connector up here that's showing with this ribbon cable connected. And you can see we've got 12 volts over there. So you can go 12 volts out of there, through common, normally open, through your strobe, back to negative again. So we've got 12 volts there. And then we've also got the other 10 outputs. So you'll notice we've got output 1, output 2, output 3, and then we go output 7 to 16. So output 4, 5 and 6 are non-existent on the M1 panel itself. They're what we call like phantom outputs, and when you put the two-way wireless on, we can use outputs 4, 5 and 6 for programming to do things. Example, we can get the night light on the wireless lux to turn on by turning outputs 4, 5 and 6 on in programming, and the system is smart enough to know, well, when I've turned that output on, we can then turn the LEDs on that night light on the two-way wireless PIRs. So the M1's got outputs 1 to 3 and then 7 to 16 voltage outputs. So those voltage outputs are good for 12 volts, 50 milliamps. If you want to activate something more substantial than 50 milliamps, such as a relay for a door lock or whatever you want to control, then you can plug a ribbon cable into there. That ribbon cable out of that straight into that relay board we spoke about before. It plugs in, and then we've got outputs 9 to 16. So you've got 8 outputs. So outputs 9 to 16. Outputs 7 and 8 are still usable on this relay board. That's done on that blue connector down there. So it's output 7 and 8 on that blue connector, which is still voltage outputs. And then output 9 to 16 are relay outputs when you plug that connector in. If you just want to control 1 or 2 relay outputs for a door strike, don't want to have to go to a full 8 relay module, then we also sell little single relays. So you can just plug a single relay, for example, straight from output 7 to negative volts, and you can just plug virtually that relay board, just a single one of those relay boards onto the system. Or you can plug the 8-way relay board on there. And then the last one down the right-hand side, down the bottom, is a 4-wire data bus that we connect to modules. It's a standard RS485 data bus that goes out. Obviously, it's encrypted, but all the rules of standard RS485 should be followed to make a troublesome-free installation. And when we do that, when we run a 485, it should really be daisy-chained when we wire a 485, not home run, but we'll have a look at this in more details. With the M1, we should ideally, in an ideal world, which there's not always an ideal world, we come out of an M1, go to the first module, the next module, the next module, the next module, etc. So we've got a definite start and end of the 485 data bus. And what we should do is terminate with an end-of-line resistor at each end, the furthest end. In this case, it's at the panel and the output expander. Doesn't mean you've got to then connect a resistor across in with the wires. The panel has got, or the modules have a end-of-line resistor built in. So all you need to do is put the link on. So in the M1, we put the link on the termination here to add the end-of-line resistor for that end. No link, no link, no link. And the one at the very end, we put the link in here to terminate that end of line. Now we've got that 485. It's balanced to both ends. Nice trouble-free installation. If I was to terminate all of them, then it's going to really throw the 485 out. If you want to home run devices, then we've got 2 different type of data bus hubs that we'll have a look at shortly. We've got the DBH and the DBHR. This one will cater everything in and out for you, so it'll go in and out, in and out, in and out. So it goes in on 1, out on 2, 3, 4, 5, etc. And this gives you an additional 4 branches that we'll have a look at. So on this example here, as I said, you have to terminate your 485 data bus at each end. So on this example, where we've got the main panel and we've got 2 keypads, what I would do is terminate JP3, put the link on there and the link on the last one on the bus. When we daisy chaining here, we've got 2 home runs going to the panel. So in this case, the panel is effectively in the middle. It's like in the middle. So we're coming in and out. So there's the first, there's the start, and there's the end, or there's the start. So they're the 2 furthest ends labeled with C and F. So in this instance, we'd put the termination in C and F, not in the panel because it's not at the end. And we go in there, nice and simple. When we want a home run, we've now introduced the DBH. It's a RJ45. It needs at least 6 wires connected into it, typically used for a Cat5 cable. So when we've home run all the modules back in, it's still going to go in and out to each module, but this module will arrange it for you. So we'll go in, out, etc. So in all this example, what we would do, we'd put the start of the line on A, it comes through, out on 1, back in 2 and 3 and 4, and then we put the RJ45 with the end of line resistor clip in there as the first and the end of the line. If we haven't run the cable in Cat5 where you've got a 6-core, you've run it in 4-core data cable, or alternatively it's a retrofit system, so they've only got 4-core alarm cable perhaps for the home run devices. We've got the DBHR, so where we had one branch of RS485 on the main panel, when we introduce this, it gives us 4 branches of RS485. Same rules follow. We've got 4 end-of-line resistors for the 4 branches, or 4 links for the 4 branches. So we follow the same rules. So let's look at the first one over here on A and B. So when we look up here, we terminate on A and terminate on B, which terminating that 485 branch. Then we've got the other 485 here. On this example, we have 2 keypads. So we terminate at the start of the run, and there's the link for that branch there. Branch B, we've got a keypad and expander, so we terminate at the start of the run and the end of the branch. Again, that we don't have the end of line in this here because it's not the end, it's the start and the end. Our third branch, on this example, we've got an expander, another expander and a keypad. So again, we don't terminate at this module here, it's at the start and at the end. And on this branch, we've got one expander on there, so we put the link at the start and at the end. If you follow those rules, then you'll have no issues with Databus cabling. When you put that link on, what it's effectively doing, it's adding a 120 ohm end-of-line resistor in. So at any time you think you've got a trouble with the Databus, something's not quite working properly, if you rang our tech support, the very first thing they do is tell us to power the whole system down, mains and battery, and put a resistance meter across A and B at each branch, and you should ideally measure 60 ohm, give or take a few ohm, for cable resistance. If you're measuring open circuit, it means you've got no end-of-line resistors at all in that branch, so it's measuring open. If you're measuring 120 ohm, then you might have your end of line on one end and not the other because you've only put 120 ohm in. Add another one in, so you've got 120 ohm and 120 ohm. In parallel, it drops it down to 60 ohm. And if you're measuring 30 ohm or something low like that, then what's happened is you've got an end-of-line resistor in all of them. So therefore, you've got 120 in parallel, 120 in parallel, 120. So you've got 120 down to 60, down to 30, and so on. You've got it's showing you straight away what the issue is. So it's critical to be able to do it. The other handy little hint, the DBHR module should be wired near the main panel. It's advisable not to wire that DBHR module out in the field and running that cable, etc. It can be done, but it can cause issues as well. So wherever possible, mount the Databus module, the hubs, in with the main panel. When we program, we've added the modules onto the bus, we have to then address them. The modules are broken into 4 different types. Type 1 is a keypad, so whether it be an LCD, navigator, touchscreen, or single door access module. The single door access module is treated as a keypad, and there's various reasons for that I won't get into here. But if you treat it as a input, like when you badge a card at the reader, it can input like you're inputting a code into a keypad. So it's classified as type 1. Type 2 is a zone expander, whether it be hardwire or wireless. So type 2 is an input expander or a wireless receiver. Type 3 is your output expander, and type 4 is your serial port expander. Now, the reason we break them into various types is so we can get the number of modules on there, and so the system knows the protocols coming in, what type they are. So on a particular M1 system, I can have, for example, a keypad at address 2, an input expander at address 2, an output expander at address 2, and a serial port expander at address 2, because they're all different types of types of modules and types of protocols coming in, they'll work happily on the system at once. But I can't put two keypads at address 2 because they'll clash with each other because they're the same type. I can't put two zone expanders on the system at address 2, again, because then we'll end up with two zones being the same. It will clash. Same with outputs and serial port expanders. So as long as they're on different types, they can be the same address, but you can't have the same address on two different types of modules. When we add modules to the bus, each one has to have a different address, as I mentioned. Keypads have to start at address 1. I have to have a keypad at address 1 all the time. And then the next keypad will be address 2, 3, 4 onwards. If I start my keypads at address number 2, the system's going to say we've lost keypad at address 1. So you always got to have one keypad at address 1 up to 16. On the expander modules, we have to start at address 2. We can't have a zone expander at address 1 because we've already got virtually a zone expander or an expansion module on the main M1. So therefore, when we add that, that expander has to start at address 2 onwards. The same with output expanders. The output expander has got to be address 2 onwards because effectively we've got our first expander built into the main board. So expanders are on 2 onwards, keypads at address 1 onwards because there's no keypad on the main board. Address 1 on keypad is enrolled in the system all the time, so you can then get into program. As soon as you've got a keypad on there at address 1, power it up, it learns itself in, and it's built into there. Keypads at address 2 onwards will not work until we go into the system and say, go and enroll the modules on the bus. Same as the expanders. Expansions modules 2 onwards will not pick a zone up or won't not work on the system until you tell the system, go out and add those systems to the bus. To address the modules on the bus, the LCD keypad, you push and hold the star button for 15 seconds. So you power the system up, push and hold the star button for 15 seconds, and then on the display, it will then say, use the up and down arrows to change the address, push exit when done. So then I use the up and down arrows to go to address 2, 3, 4, or whatever you want, hit the exit button to save it, and then that keypad is now set for that address. The navigator keypad's slightly different. When you first power the navigator keypad up, there'll be, for about 5 seconds, will flash on the screen, a button that comes up on there that will tell you to change the address. And you push that button, they'll all be set for address 1 out of the factory. You set the next keypad to address 2, then the next one at 3, 4, 5, etc. to you address the keypads to the ones you want. With the expansion modules, input and output expanders, they have dip switches on them to set the address. It's done in binary, so you put 1 on for address 1, 2 on for address 2, 1 and 2 on for address 3, and so on. So in this example here, little handy hint, don't look at the numbers that are on the switch themselves because that's just a generic switch we use on the modules. But on the circuit board should be silk screen 1, 2, 4, 8. So you follow that to add them. So you put 1 on for 1, 2 on for 2, 2 and 1 for 3. So on this example here, we've got 8 on, plus 2 on, plus 1 on. It's address number 11. Okay, so we've got switch 1, 2, and 8 on is address number 11. So it just adds it up like that. And also in the manual, it does show you a guide if you can't count. So when we set the address on, for example, an input expander, the address will then set what zone it is. So the main board, which is effectively address number 1, is for zones 1 to 16. If I had a zone expander at address number 3, so we've got 2 on plus 1 on is address 3, it zones 33 and 48 in programming. If it was an output expander at address 3, again, it's output 33 to output 48. So we can build up right down to 208 inputs and 208 outputs. It's not really a true 208 outputs because keeping in mind that outputs 4, 5, and 6 on the main panel aren't there, so it drops it down to 205. In a roundabout way, we can add something to get it back to 208. We've never had to yet, but that's how we know by what the address of the module is when we're programming it. I want to switch output number 97 on. We know what output that's going to be on that particular module when programming. So once we've added the module on the bus, we've wired it properly, we've added the correct end-of-line resistors for the start and the end of the bus, we've set the dip switches or addressed them correctly, we now have to tell the M1 to go and poll your data bus and add the modules onto the bus. To do that, we do it in program mode via the keypad, or we can do it from the programming software, LKP software. To do it on the keypad, we just simply hit the menu button. We then go across to install the programming, and the very first option, install the program, is bus module enrollment. So when we press menu, we go across to installation programming. It will ask us for the installation code. You have to know what the installer code is. And as default, it's 172839. And how am I going to remember that? It's 172839. Top, bottom, top, bottom, top, bottom. It will then take you to install program mode. And the very first option, as I mentioned, is bus module enrollment. When I push bus module enrollment, all the modules, including keypad address 1, will drop offline, get unenrolled, and then they go in and get enrolled, scans the bus, and will add all the modules it's found on the bus at that time, and it will then come back and tell us how many bus modules it's found. We can then go and search and view the number of bus modules it found, see what they are. In case you had 8 modules and it only found 7, you can go and see which ones it's missing, go back to the one that's missing. Oops, I forgot to plug the connector in, plug it in, and then you do another bus module enrollment, and it'll add the ones that you've done. If for some reason you need to take a module off the bus, perhaps you added another zone expander too many and realize you didn't need it, or an output expander, if you just unplug the module from the bus once it's been enrolled, it will come up as an alert to say we've lost a bus module. To take it off the module, you then unplug it and then do another bus module enrollment. It will then take them all out and re-enroll them, the ones that it finds on the bus at that time. That's how you take it off the bus once it has been enrolled. We'll now have a look at the operation of the system, the keypads, what all the buttons mean, what we do. Is there any questions up until this point of what modules can go on the bus, how to do the bus module, how to enroll it, how to address it, or anything like that? No, everyone's good, no questions. All right, so we'll have a look now at the operation of the system.